What is the balanced chemical equation for liquid methanol combusted in oxygen gas to yield carbon dioxide gas and liquid water? So this is an example of a combustion reaction. And first, let's write down all of our reactants and products and the state that they're in. So we have methanol, which is a liquid. It was combusted in oxygen gas, so O2 gas. Then my reaction arrow, and this takes place under heat, so I'll put that little triangle top of the reaction arrow. And our products are CO2 gas and H2O liquid. Okay, so normally when I balance combustion reactions, I like to balance out my carbons first, since there's usually multiple carbons in the reactant side. But in the case of methanol, there's still only one carbon, so I'm going to skip balancing the carbons. And I'm just going to balance out my hydrogens next. So you'll see there are 4 hydrogens on our reactant side and only 2 on our product side. So step 1, balance out the hydrogens. So there's 4, so I need to add a coefficient of 2 in front of water. And now you'll see that this affected the number of oxygens as well. So now we have 4 oxygens on our reactant side, but we have an odd number of oxygens on our we have an even number of oxygens on our product side and an odd number of oxygens on our reactant side. So in times like this, I would need to add a coefficient of 3/2 in front of my O2 in order to also get 4 oxygens on both sides. So you'll notice that since I only had 3 on this side, I wanted to add a coefficient in front of my O2, just however many remaining oxygens I needed, and then divided by 2, just so that it will cancel out that O2. Okay, so step 2 was to balance out the oxygens. And now notice that my coefficient contains a fraction. So I'm going to multiply by 2 to get rid of the fraction. So when we multiply, we want to do this to the whole reaction. And then our new balanced equation is 2 methanol plus 3 oxygens makes 2 CO2 gas plus 4 H2O liquid. Okay, so let's see what the junior tutor said. To balance a chemical reaction, we can use the method of inspection. And this method, we multiply the species that we are to balance by a coefficient. First, balance the elements that are not oxygen and hydrogen. Then we balance whichever is simpler. To start, we translate the reaction into a chemical equation. So since carbon appears to be balanced already, we proceed by balancing hydrogens. We balance hydrogen before oxygen since hydrogen only appears in two species. The result is shown below. Okay, so they put the 2 in front of H2O. Next, we balance the oxygen. The easiest way to do this is to multiply 2 to the methanol. Okay, so they put their 2 in front of methanol first. Then they say that this makes carbon and hydrogen imbalanced, so we need to adjust accordingly. So then they just switched their coefficient of 2 to a coefficient of 4, and then put a 2 in front of carbon dioxide. Now we need to balance oxygen for the final time. The balanced chemical equation for the combustion of liquid methanol and oxygen is shown in equation 1. Yep, so they ended up with the same balanced equation. So there are two different ways you can go about answering this question. It just depends on whether or not you like to deal with the fractions, or if you don't mind going back a few steps to fix your coefficients. Okay, so this solution is correct.